Hey everyone, I used to think DSA was just for interviews and didn't have any much real world value. Maybe you feel the same way, right? But after working through a few examples, I started to see how DSA actually makes code faster and more efficient. Today, we are diving into why DSA matters and where it has real impact. Let's start with a classic example to keep things simple, the two-sum problem. First, let's take a quick look at what the two-sum problem actually is. It's pretty straightforward. We need to find two numbers in a list that adds up to a target number. Seems simple and small, right? But where do we use it in the real world? Hmm, Okay. For example, a diet app or a nutritional app could use two-sum to find food combinations that match a specific calorie goal. This shows that two-sum isn't just a practice problem. It's a concept that has real-world application in different scenarios. Different scenarios in the sense, other than diet app, we can use it for multiple purposes. So now I'm not going to bore you with the details of how brute force and optimized code work. I'll keep this simple. If you are interested in the specifics, check out other videos that go into the code step by step. My goal here is to convince you with clear proof that DSA really does make a difference. Before we dive into the solutions, let's talk about how I'll demonstrate the importance of DSA by measuring its performance. We'll gradually increase the size of the list, which in this case represents a list of food items with their calorie values, trying to back to our real world example of matching food combinations to a calorie goal. As we expand this list, the number of possible combination grows, making the problem more complex. This way, we'll see how each method performs as the data scales up, helping us understand the efficiency of each approach as it handles larger inputs. We'll solve this problem with two approaches, a basic brute force approach and an optimized one. Then we'll test both approaches by gradually increasing the list size to see the performance difference and better understand how DSA efficiency in real applications. I hope you can see my code here. So my to my left hand side, I have a brute force solution. I don't want to dive into more specifics. This is the actual code for two sum problem, and this is the to my right hand side. It is the optimized version of same solving the brute force two sum problem. Here is the approach, but I don't want to go into specifics. Before that, I'll just explain what does it do here. So here is the measure performance functionality where we actually measure the performance time by 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 recording a start time before the function starts and ending right after the measuring the time right after the function ends, and we are just listing it down. Okay, so initially we are going to set the target of 24, and the initial size is going to be 100, and we need a random list, right? So for random list, I have added a small function here to give me a list of numbers which are from 1 to 10,000. I'll explain why it is 10,000. The size is like whatever we provide here. So this 10,000 is like, so for example, now our size is just 100 numbers in the list. So if I give 100 here and my target is 24, this would complete it in a few seconds, because any number in a list of 100 list of 100 numbers, it can happen. This 24 can be in a first index or 10th index or 20th index. It can be that, right? What if there are no numbers which are equal to 24? Then we will not have an actual two sum problem here, right? So in that scenario, we should return a none, and then it should check the whole list and tell me it's not there. I don't have any matching number here. Okay, so that's why we have this 24 and the size is 10,000. To my right side, the same thing to the measure performance, generate random list, same size, same number, everything is same. Even the target is same. Okay, so okay, shall we dive? Shall we go into the real problem here or problem solution here? Okay, I'll open this two different terminal so that I can show you that it's side by side. Okay, so for a list of 100 items, it's solved in like in some milliseconds. Okay, let's test our optimized version of it. Hmm, is it better? Yeah, I guess so. From the look of it, I can say it's bigger. I mean, the time taken to solve this 100 list of numbers was fast. So let's make it spicier by adding a one more zero here. So now the time has taken more. Okay, let's do the same here. Okay, I want to save this. Enter. Okay, I think the decimals are in still the same level, unlike this brute force. I'll add one more number. Okay, that was also quick. So let me just make it another here so that we can compare. Okay, I think this has easily increased its value, and this has also increased. Wow, that was expected, right? Let's do one more. Here it is taking time, but our optimized solution will be faster. Let's see, and see. But I think it's still stuck here, right? Hmm. Oh my God, that's more. 15 seconds is a lot more, but we'll do one round. But I don't know whether it will complete in under 30 seconds. Okay, that was pretty quick. Hmm. But still, it did not beat our optimized performance. I'll tell you why the last one got finished quickly. As the numbers are very random here, the target value which we are looking to could be very stark. As you can see, the first index was 5 and the next was like 19,330 something. But here it says like 837 and 3119. Let me do one more here so that you know that the numbers are really random. So it does not give you the same value again. Hmm. I think it is taking time, right? Let's wait another, I don't know, let it end. Okay. It's really taking time. So I'll just cut the video here and then come back when it ends. Wow, my God. I'm back, but it took me like 51 seconds to complete this thing, which is really, really more. But our optimized solution did not even touch a second, like half a second. It was everything is like still in milliseconds. To show that I can run another one here, still it close. I mean, it completed even before this, but the index looks very bigger than that. I can do another one, still the same. Okay. So now we can see that, right, for 100, it did not make much difference because everything looks like in the thousandth of a second. But in the next 1,000 items itself, it was making us a great difference because it was like hundredth of a second, and this is like a thousandth of a second still. And for 10,000 items list of numbers here, it was like 0.09. It's still in like 100, and here it is like it became thousand, I guess. And for 1 lakh, it was taking 15 seconds. But here, still it was in milliseconds. And fortunately, for 10 lakhs, it gave me first 0 0.5 seconds. But for the next iteration, to make it very random, it gave me 51 seconds. And for uh, 10 lakhs or 1 lakh here, everything was almost in the same region, right? So from this, what we can say, so running the code, we see a clear difference in execution time, right? The brute force approach takes several seconds, but the optimized version completes in milliseconds. Yeah, milliseconds. So this example highlights why DSA is very important. First thing, efficiency. The optimized solution is much faster, right? The second one, as the input grows, the difference becomes even more pronounced. And the third one is DSA helps you design better solutions, right? So, but the conclusion here is you don't need to memorize every algorithm But understanding DSA principles can drastically improve your coding efficiency and problem solving skills. It's not just for interviews. It's about writing better and more efficient code. What do you think? Has this changed your view on DSA? Let me know in the comments and don't forget to like and subscribe for more of me.